Small intestine. It receives partially digested food chyme from the stomach and secretes enzymes to complete the digestive process. It is made of mucosa formed of epithelium, corium, and muscularis mucosa, and submucosa, musculosa, and outer serosa. Mucosa. Mucosa of the small intestine shows the presence of a large number of folds or plicae, plicae circularis, or valves of cracking arranged circularly around the lumen and are most prominent in the jejunum. The surface of the plicae showed finger-like projections. The villi protrude into the intestinal lumen, and simple tubular glands, the crypts of Lipperkin. The villi are covered with simple columnar absorbing cells, about 90%, goblet cells, about 9%, and enteroendocrine cells, or APUD cells, about half or 1%. The villus core is formed of loose connective tissue containing blood vessels, nerves, and lymphatics, which are called central lacteals. Crypts of Lipperkin are simple tubular glands extending from the base of intestinal villi to muscularis mucosa. They are lined by simple columnar absorbing cells, goblet cells, enteroendocrine cells, similar to intestinal villi, together with Paneth cells present at the bottom of the crypt, cavulated cells, stem cells, and M cells. Epithelial lining the intestine. Cells having the characters of protein synthesizing cells as columnar absorbing cells. They are tall columnar cells with basal oval nuclei. Their free borders are striated, rich in alkaline phosphatase enzyme, which plays a role in sugar absorption. By electron microscope, the striated border is found to be formed of microvilli to increase the surface of absorption. The cells show the usual picture of protein synthesizing cells, that is, well-developed Golgi apparatus, mitochondria, rough endoplasmic reticulum, as well as free ribosomes. Goblet cells. They are unicellular mucus-secreting glands found scattered between the columnar cells. The apical part is distended with mucin, while the basal part is cylindrical with an oval darkly stained nucleus. They secrete mucus at intervals for protection and lubrication. By electron microscope, they show the usual picture of protein synthesizing cells. Paneth cells, they are only found in the bottom of the intestinal crypts. They are pyramidal cells with basal rounded nuclei. They secrete intestinal and bacteriolytic enzymes. By electron microscope, they contain apical acidophilic secretory granules and the usual picture of protein synthesizing cells. Their basal part is basophilic, containing rough endoplasmic reticulum, together with Golgi apparatus and numerous mitochondria, as other protein synthesizing cells. Other cells are argentaphene or enteroendocrine cells, or ABUD cells. In the intestine, they secrete, besides the usual hormones, somatostatin, serotonin, and endorphin, intestinal hormones, which are secretin, pancreozymin, and mutilin. Other cells are cavulated cells. They are low columnar cells with cavulated cytoplasm and microvilli on their free surfaces. They have unknown function. Then finally, there is undifferentiated columnar cells or stem cells. They line the basal half of the intestinal glands and they can differentiate to give rise to any of the previous types.
APUD cells or enteroendocrine cells. They cover the intestinal villi and line the intestinal crypts. These cells do not appear in ordinary sections, that is, hematoxylin and eosine sections. Their cytoplasm contains granules that can be stained black with silver and brown with chromium salts, dichromate salts. They are pyramidal cells with darkly stained round nucleus. By electron microscope, the cells show scattered mitochondria, rough endoplasmic reticulum, Golgi apparatus, and numerous membrane-bound electron-dense neurosecretory granules in electron-lucent cytoplasm. The apical part of the cells shows microvilli, which acts as chemoreceptor.
Other important cells are M cells, present in the intestinal epithelium overlying lymphatic nodules. They are mainly present in large intestine and the ileum. They have microvilli on the surface. They take macromolecules from the intestinal lumen and transport them in membrane-bound vesicles to intraepithelial lymphocytes, which in turn migrate to various lymphocytic aggregations, transporting informations to sites of antibody production. Immune role.
Small intestine. The wall of the small intestine is composed of 4 layers. Mucosa, epithelium, simple columnar absorbing cells, covers the villi and lines the crypts. Corium, loose areolar connective tissue containing blood vessels, lymphatics, and nerve fibers. Connective tissue corium surrounds the crypts and extends to form the villus core. Muscularis mucosa, inner circular and outer longitudinal layer. Submucosa, loose areolar connective tissue containing blood vessels, lymphatics, and nerve fibers. Brunner's glands are present in the first part of the small intestine, the duodenum. The second part of the intestine, the jejunum, the submucosa, contains only blood vessels and lymphatics. In the third part of the small intestine, which is the ileum, Peyer's patches, which are lymphatic follicles, are present in C-shaped appearance of the submucosa. Musculosa, inner circular and outer longitudinal layers, and apex or myenteric plexus of nerves is found between the muscles. Serosa, loose connective tissue containing blood vessels, nerves, and covered with mesothelium. Segments of small intestine. Small intestine is divided into duodenum, jejunum, and ileum. Histologically, they are different. In order to differentiate between the three segments, we have to consider the different layers of the alimentary canal. Mucosa, villi. Duodenum is characterized by broad and leaf-like villi. Jejunum is characterized by long and slender villi. Ileum is characterized by long and slender villi present on the surface, but these villi became short, filiform, or absent over the Peyer's patches. Epithelium of the duodenum is characterized by few goblet cells and few M cells. Epithelium of the jejunum is characterized by numerous goblet cells and few M cells. On the other hand, the epithelium of the ileum is characterized by numerous goblet cells to lubricate the fecal material and numerous M cells over the Peyer's patches. Submucosa of the duodenum is made of loose areolar connective tissue containing blood vessels, lymphatics, nerve fibers, and Brunner's glands. Brunner's glands are compound tubuloalveolar mucus-secreting glands. Their ducts open into the bases of the crypts. Submucosa of the jejunum is also loose areolar connective tissue containing blood vessels, lymphatics, nerve fibers. There is no glands or Peyer's patches. Submucosa of the ileum is also loose areolar connective tissue containing blood vessels, lymphatics, nerve fibers, and Peyer's patches, which are lymphocytic aggregations. These patches are found on one side, anti-mesenteric border, giving a C-shaped appearance extending from the submucosa to the corium, masking the muscularis mucosa. The rest of the wall of the small intestine is the same. Musculosa is formed of inner circular and outer longitudinal smooth muscle fibers in the duodenum, jejunum, and ileum. Serosa is formed of loose connective tissue covered by mesothelium in the duodenum, jejunum, and ileum. Function of the duodenum. Brunner's glands present in the submucosa of the duodenum secrete alkaline mucus to protect the intestinal epithelium from the acidic chyme coming from the stomach. Their secretion also maintains the optimum pH for pancreatic enzymes. Jejunum. Its main function is absorption, as its submucosa is free from glands or Peyer's patches. Therefore, it is packed with blood vessels and lacteals, central lacteals, present in the core of the villi. Submucosa of the ileum contains aggregations of lymphocytes, Peyer's patches, important for immunological activity, to protect against viruses and bacterial invasions.